Okay, let's go for our speaker's introduction. So we are welcoming today two gentlemen from Ansys that will introduce their solution to connect Capella and ModelCenter. Alexandre is Senior Application Engineer. He works closely with sales engineer and pre-sales initiatives for product demonstration to opportunity assessments. He is also providing training and post-sales support for Ansys model-based engineering solutions, supporting customers in their digital transformation journey. And Scott Ragon is MBSE product manager at Ansys. Scott has more than 20 years of engineering, modeling, and simulation and optimization experiences. So glad you both are with us, and I will leave you now the virtual floor.
All right, I can get started on the first slide, and then I will hand it over to my colleague Scott here with us. So hi everyone, I'm really glad to be with you today. I'm happy that we have so many people connected and online right now. I know it's late in Europe, but and it's vacation time, but I'm glad you're all here. So regarding today's webinar, we decided to have the following agenda. So my colleague Scott will talk about MBSE and Ansys to start with. Then I will go into a technical demo because that's really, the motto for today's webinar. We want to show you things, and we want you basically to provide us with your feedback. So what do you think? What do you like? What would you like to see implemented in the connector? So we prepared a series of questions that we'll ask you throughout the webinar. And yeah, we will also present a couple of use cases. It's one use case with like 4 different parts that I will present. And of course, at the end, like Samuel explained, we will have a dedicated Q&A session. So that being said, I will open the floor to my colleague Scott here on the call.
Okay, thank you, Alex. And I want to echo Alex's welcome to everybody who's online today. I'm going to start by giving a very brief introduction to MBSE. And I know I don't really have to explain MBSE to this audience, but I want to make sure we're all on the same page. And then I'm going to talk about what Ansys does in MBSE. It might be a surprise for you to see Ansys and MBSE together. And it's all going to be a build up to Alex's demonstration, because one of the key things that we do with MBSE at Ansys is to bring engineering analysis and simulation together with MBSE. So what is MBSE? MBSE is simply doing systems engineering with models, and I think we all understand that. It's the use of a model-based approach to do systems engineering instead of a traditional document-based approach. And finally, it's important to understand MBSE is not something that you just do once and you're done, but it is something that is used throughout the product lifecycle. So MBSE, a lot of people, this slide is from NASA, I'm sure everyone has seen it. It's a transition from the document-based approach on the left, where the system architecture is described using documents, whether they're electronic documents or actually paper documents. That's the traditional way people did systems engineering. And communication was done using documents also. So MBSE is about transitioning from the picture on the left, which frankly can be chaos as the system complexity grows, as the number of people grow, into a more structured model-based approach where there is a central systems architecture model that acts as the authoritative source of truth for describing the systems architecture and communicating with everybody else. So that's what's at the heart of MBSE. Moving to the next slide then. We talk about model-based systems engineering, and it's important to understand, what do we mean by models? Well, first of all, we mean the systems architecture model. I've already said that. This is the detailed description of the system being defined. And I emphasize description because it's a descriptive model, not an executable model normally. And that descriptive model needs to be supplemented with engineering analysis and simulation. And those two types of models together are what we mean when we say model-based systems engineering. And you need both of them. And you use the engineering analysis. It's an important component of this, of course, because that's how you verify that the system that you're designing, that you're describing, is actually going to meet the physical and behavior requirements that it needs to meet. So model-based systems engineering are both of these things. Now, what are the benefits of MBSE? I think we all understand the reason we're all here is we know that MBSE promises to dramatically improve product development. It does that by providing a structured way to manage the increased complexity that's associated with today's systems. Automotive, aerospace and defense, all modern products really are more complex today than they've ever been, and MBSE is a way to manage that. And by managing that complexity, you're reducing cost, you're getting to market quicker, you're reducing schedule, and that means that the risk of developing a complex system is going down. And then at the end of the day, it's all about designing a better system. And that's the last bullet here, Alex. Design better products is what MBSE is all about. So who is implementing MBSE then? I mentioned before, aerospace and defense and automotive are probably the primary industries that are implementing MBSE, but it really has the potential to benefit anybody who's designing a complex product. And as you go out and look at what people are doing, you see that some organizations are implementing MBSE because they are mandated to do so. And that's particularly true in the US, because the US Department of Defense is mandating the use of MBSE on major weapons programs. They're doing that because historically there have been tremendous cost overruns and tremendous schedule delays with weapon systems, and the Department of Defense sees MBSE as a way to reduce that. So a lot of people are implementing MBSE because they're being told by the US Department of Defense that they have to do it. But probably more important for this audience, others are doing it because they see the clear benefits that we talked about in a previous slide. And I like to use this quote from Ford Motor Company, Robert Worthland. He says during one of our webinars that as a company, they're seeing the kinds of returns, in other words, returns on investment that people are talking about with MBSE. He says we can count in the millions of dollars the bookable savings we've been able to come across in just a few limited applications. So nobody is mandating that automotive companies implement MBSE, but a lot of them are doing it because they see the benefits. Okay, so let's move on from what is MBSE to how you implement it. And I think it's important to understand, and I'm sure everybody here does, is that MBSE is not a tool. You can't buy a tool from Ansys and say, now I'm going to do MBSE. But MBSE is a methodology that you follow throughout the entire product lifecycle, starting at the very beginning of the product lifecycle, from the requirements and the concept design, and you follow it all the way through to detailed design and beyond. So MBSE is a methodology, and if you go ahead and hit forward two times, Alex, to implement this methodology, you need a lot of different tools working together in a seamless way. You need a way to capture and manage your requirements. You need a way to describe and share your systems architecture. And then you need, as I said earlier, you need to connect that systems architecture model to engineering analysis. And there are a number of tools that can be used for all these different functions. For requirements management, there are products on the market like Doors that allow you to manage your requirements. There's Codebeamer, there's JAMA, there's Polarian, for example. For systems architecture modeling, there are a lot of options. There are a lot of SysML tools on the market. You can see some of them here, like Cameo and Rhapsody. PTC has a tool called Windchill Modeler. But there are non-SysML tools that a lot of people use. And for this audience, obviously, Capella is probably the most widely used tool that goes into that category. And then there is a whole world of engineering analysis tools, everything from spreadsheets to MATLAB scripts to Python scripts, all the way up to full 3D physics analyses like we have here at Ansys. All of these are important as well. They're used to validate, to verify the requirements that your system has to meet to make sure your system is behaving and acting the way it needs to. And these analysis tools are also used to optimize your system design. You might find that you're not meeting all the requirements, and you might ask yourself, well, how do I meet the requirements? These analysis tools in conjunction with the systems architecture model are a way to do that. So moving forward then, why is Ansys involved with MBSE? Well, first of all, I just want to state that Ansys has been in the MBSE world for a long time. We have tools such as SCADE that allows you to design safety critical embedded software. We have tools such as Medini Analyze that allow you to make sure that your system is safe. And we can supplement those tools with tools such as ModelCenter, which I want to focus on in today's talk. So going on to the next slide, I think we've already talked about this. We know what the systems architecture model is. It's an authoritative source of information about the system design, but it's not executable. It's a descriptive model. And moving on to the next slide, we all understand that the system architecture model describes the system. It doesn't analyze the system. So it needs to be connected to engineering analysis. And again, that analysis can be anything from a spreadsheet up to a full 3D physics analysis. And this connection is where Ansys comes in. And in particular, this is what ModelCenter does. So ModelCenter acts as the bridge between the system architecture model, as depicted here on the left, and the world of engineering analysis and simulation, as depicted here on the right. So ModelCenter connects your system architecture model to the world of simulation and analysis. And yeah, so MBSE integration is one way to describe that. And I want to emphasize that ModelCenter works with any engineering analysis tool that you might want to use. It's not specific to Ansys tools, but of course it works with Ansys tools, but anything you want to use to analyze your requirements, verify and validate your requirements, ModelCenter can we can automate those using ModelCenter and connect those simulation and analysis tools to the systems architecture model. And it's this connection between the systems architecture model and the world of engineering analysis that accounts for a lot of our activity in the MBSE world. And what we want to talk to you about today, if it's not already obvious, is we want to show you how this works in the context of Capella. So we're going to show you we're going to give you a demonstration of the ModelCenter connector for Capella that allows Capella to be connected to engineering analysis, any engineering analysis you want. And it's not just single analyses, but entire engineering workflows can be connected to the engineering, to the systems architecture model. So this is the context of today's demonstration, and I'm going to turn the floor over now to Alex, and he will demonstrate how all this works with Capella. And we have several poll questions here for you, partially just to understand what our audience looks like, and of course to keep everybody awake. So the first poll question you can see here, I don't have to read it for you, but what part of the design process, in what part of the design process do you use Capella?
All right, I think we can leave it here. So Bessel, maybe I will close the poll to see the results. Yep, perfect. Close, and can I see the results here? I think we can't display them. So we have 41% of the audience that is using Capella for conceptual design. Then we have less and less using Capella throughout the entire phases, basically. We have only 33 for preliminary design, then only 22 all the way to detailed design, and only 3% for production and others. So I don't know, Scott, how if you want to react to it. I've been watching a couple of surveys that OBO sent over to the Capella community before, so it's not surprising to me, but it's encouraging because it's only for conceptual, but I believe that simulation starts to add value from the conceptual stage all the way to detailed design, and having a bridge between simulation and system architecture modeling could maybe potentially help bringing Capella, not only using it in conceptual, but towards preliminary and detailed design. So I don't know if you want to add to this.
No, I agree, Alex. And that is basically what we see when we look at the customers who use this technology, is most of them are doing conceptual design.
All right, perfect. So I'm glad it worked. So we will transition over to the technical demo. So hopefully you still see my slides. So regarding the demonstration objectives, I have listed a few, and it's really important, right? I want to be fully transparent with you. This demo is based on a well-known example in the Capella community. So we wanted to use something that is being known by the community, so that it can resonate with you guys, and it will also be based on the Arcadia methodology. The model needs, and the use case needs to be simple to allow you to focus on understanding the design process. So of course we didn't start by, like taking something over like too complex. We just want to show you the mechanisms and how the connector works and gather your feedback so that then we can potentially start developing something with you all. We want obviously to show you the connector capabilities, be transparent regarding the current limitation of the connector. So currently we have something that is similar to a beta version. So of course, not everything is working, the best it could, but it's good enough to being used already. And last but not least, we want to get feedback from you guys. So we're gonna ask you another poll questions at the end, and please, give us some feedback in the survey. So regarding the use case, well, I've been, looking up on Google a little, and yeah, I mean, what sounds apparent to me is that this, in-flight entertainment system is the best one that we could use, but it looks a little bit too complex, I think, for this kind of webinar. And I came across this example from Peter Jackson, so head of Pillar Engineering Systems and Design from the Singapore University of Technology and Design. That put together a tutorial around Capella and the Arcadia methodology. And for this tutorial, he decided to use the example of a toy catapult. So, I think it's a kind of funny application, and it's simple enough to be able to show the value we can have. So he was touching on a few points already in a webinar 4 years ago, talking about the Arcadia methodology, about the Capella also, about Capella, the tool and the modeling language in it for systems architecture. And he had the same goal, basically, right? Education, right? So the target audience was engineering students, but it also helps, new users of Capella to get up to speed, right? He wanted to teach the 3 first levels of the Arcadia approach. And that's good because we're going to take it from there, basically. And we're going to see how we can extend this work with our technology. So there is a landing page for this tutorial. I have a link below. So I'm thankful that he shared, gave us the green light to reuse it and to point to it in our webinar. In terms of Arcadia viewpoints, you can see, I'm pretty sure that most of you in the audience are familiar with it. But Capella supports the Arcadia methodology, right? And you can see that you have a construction, like you can see vertically, operational analysis, then you have, system architecture, logical architecture, and then physical architecture. So you have different layers. At the top, the goal is to understand the need, right? Like understand and capture the problem space. And as we go down, we have more viewpoints. And of course, we connect the different entities across the different layers. And we're trying to go in the solution space, right? And you can see that the requirements are flying over here in the middle. So in terms of what has been done in the tutorial, I'm not going to go over everything, right? But it went all the way to the logical architecture. Well, you can see we have the toy catapult system, the system of interest with different logical components, different actors that are interacting with it, and a bunch of functions, right? So the tutorial stops there and doesn't go into physical architecture. So the author expresses the need to use simulation model to execute the descriptive model that has been created in Capella and to carry out trade studies at this stage, right? So which type of catapult should we use? Can we use simulation models to basically ensure the system is going to behave properly and satisfy our requirements? And it can not only bring value here, it could have brought value earlier, like in the logical architecture stage, for instance. So before I go into the live demo, we'll please ask Bethelen to ask you the second question in the poll. And I think it has something to do with, what level of analysis do you and your team perform prior to detailed design? And I think that's a really important question here. I hope we're gonna get as many answers as before. So see the first answers that are flying in. We have about 10 answers. That's good. 39 answers, so you're quick. That's great. I don't want to lose too much time for this one. So let's close the poll. All right. So the results we got is extensive use of simulation prior to detailed design, 24%. The majority is some type of analysis before prior design, 36%, and then not enough, 28%. We just have a few of you guys that are not using any analysis before detailed design. What I take away from there is that, you know, we have like 30% of you guys that think that you're not using analysis enough. And the reason might be that actually you don't have the connection to Capella, for instance. So I will take it from there. So we decided to use this toy catapult example. The tutorial provides some context. We decided to show you how to implement trade studies as desired in the tutorial. We're going to focus on the physical architecture layer, even though the tool could be used before, once again, right? We're going to specifically work on the physical architecture layer in the demo. And we had limited resources. I think you can get it. So we have not been able basically to go into the Capella model and change everything, right? So we use that as a starting point, the toy catapult. But on the simulation side and for the physical architecture, we decided to go for something more real. So when I talk about real catapults, you know, like a couple of hundreds of kilograms, throwing distance of about like 20 meters. Hopefully you can't achieve that with a kid's toy, otherwise it could become dangerous. And there were a few relevant informations that I would like to share with you at this point. So we are aware that requirements viewpoint and PVMT are widely used within the Capella community. So we decided to show that we can actually connect to those with ModelCenter, right? And we've been working mostly with class diagrams. And I will get back to it later. Again, we don't support a connection with every single types of entities in Capella. So we started by connecting to class diagrams. So the first part will be focusing on the process integration. That's the starting point before we go into the MBSE connectivity part. So what we have been doing basically is to start from 0D, 1D models, right? Otherwise the models would take too long to run for this webinar. So we decided to introduce a couple of catalogs for the catapult. So for the wheel, for the bucket, for the aiming system, right? We came up with some spreadsheets with kind of like some databases, right? You can change the type of material. And of course, it's going to change the cost and the mass and the performance. We've been automating that with ModelCenter on the right. So you can see that we automated Excel, we did the same with MATLAB. So we have a cool animation here on the right. And we have also been using a couple of Python scripts. But again, that's what I would like you to take away. It doesn't really matter which type of simulation tool you're using. There is a big chance that we can automate it in ModelCenter. So I will go into the live demo at this stage. So I was talking about the Excel model. So that's something like this, right? So where you can change the type of the bucket, for instance, from wood to iron. It's changing the cost, the mass, and the diameter. Also going into some scripts. So Python script, for instance. So at the bottom, we can see that you have like a typical, really simple Python script here used to calculate the total mass of the system based on the mass of the different components. So you can see that this is basically an extension of the Python script to be understood by ModelCenter so that you can easily, you know, like automate it and run it automatically. So at the top, we are basically defining the set of inputs and outputs for ModelCenter to understand. And for MATLAB, that's really much the same thing. So we started off with a model, open source model available online that basically does two things: simulates the catapult launching the projectile and simulating the projectile flying through the air. So you can see that we are basically here defining a couple of input parameters, and then we're using OD45 for simulation of launch. When we want to go into ModelCenter, we have a dedicated plugin to automate MATLAB. We have to change a couple of things in the MATLAB model. Here, we are basically adding a header at the top to declare the variables that are introduced in the MATLAB script and that we want to make visible in ModelCenter in our workflow. And we have to comment out the initialization part of the MATLAB script because Otherwise, MATLAB will disregard the changes we make in the MATLAB in the ModelCenter workflow. So what does it look like in ModelCenter? So ModelCenter looks like this. You can see here that I created a simple workflow to automate the MATLAB file. You can see at the bottom here that we have a whole range of plugins available off the shelf to automate different type of solutions. And on the left, you can see basically all of the MATLAB variables that we extracted from the MATLAB model and that we can now make available directly for the user in ModelCenter. So here I'm automating MATLAB. So this is what the plugin looks like. I just had to call the existing M file, for instance. ModelCenter is taking care of generating a script to execute it, and is automatically detecting all of the variables contained in the MATLAB script here. So I'm kind of happy because at this stage, I can pilot, the execution of the MATLAB script directly from ModelCenter. And here you can see an execution. So that's in real time, right? We can see the simulation of the trajectory, and you can see that the catapult is throwing around 25 meters distance. And we directly get the results inside ModelCenter. So I don't want to spend too much time on that, but the idea is to build more or less complex workflows, right? So it's a process integrator. So you can imagine creating complex tool chains. Here it's 0D, 1D, but you can imagine having more complex solvers down the line. That's also possible. And what we did at this stage is that we saved all of the analysis we want to connect to Capella into a specific repository on my machine. And this set of analysis will be made available to be connected to Capella. And that will be the object of my second part here. So I'm getting back to my slides. I will go to the part 2 of the demo, right? And that's the interesting piece, right? What about Capella connectivity? So what did we do in the Capella model? What did I do? So first of all, I added some requirements, non-functional requirements for the catapults because there were none in the model, right? So the catapult should throw a projectile of less than 2 kilograms, further than 20 meters. The total production cost must be lower than $600. The total mass must be lower than 500 grams. I have accuracy requirements. I have, size requirements as well. So we created these requirements using requirement viewpoints. So we could deal and actually connect to requirements imported as from RecIF files, for instance. I created a class diagram, as you can see here. So it's a little bit similar to a block definition diagram in SysML, right? I know that it's not being used by everyone in the Capella community, like 50% of the community using them, some others using directly like physical packages. So I decided to go for this. So I created different blocks, as you can see, different classes, different connections, here aggregations, decompositions between the different classes. And I used PVMT plugin to define some mass and cost parameters so that we can use mass and cost for the different components. And I also used, generic properties that I created directly from Capella. I also, you can see here in the model that we have some multiplicity in the model to show you that ModelCenter supports multiplicity here. And we actually created links between the requirements and different properties in the class diagram. So that's our starting point. So we created non-functional requirements, and we created classes with properties, property values created from PVMT, and multiplicity. How does it work, the plugin? So the ModelCenter plugin is available directly in Capella. So you right-click on the project, and you can see here, launch ModelCenter MBSE. So once you start the plugin, you will see, that's part of the plugin that you see here. ModelCenter will basically parse and extract information from the Capella model. So as you can see here at the top, we are basically displaying different packages in the system with the different layers here. And you can see that in the data folder, we have the different classes and the different properties and value properties. Different limitation of the plugin. The connector is configured to only convert some specific Capella objects. So we went into a little bit of trouble, for instance, trying to parse parameters from physical packages, where the physical package is not interpreted the right way by the tool. But again, that can be easily fixed, I think. So we'd like to know from you guys which type of parameters and on by which type of entities you would like to see displayed in the connector. And of course, we can see the requirements. So once we have that, we have a console analysis editor to basically select the simulation black box that we created in ModelCenter. So we can see the list of inputs and outputs in the ModelCenter workflow. And we can connect it to relevant parameters of the Capella model on the left. So it's a single interface for any type of simulation. There is an auto link and there is unit checking so that you're sure that you connect your simulation variables to the source of truth in terms of system architecture. And once you're done, you can actually run simulations directly from the Capella interface. Know if the results are going up or down, and if your system is satisfying the requirements. So at this stage, I would like, big limitation that I would like to share with you. I think it won't take too much to fix it, but at this stage, we can extract data from Capella, but we can't push back. So I know that the Capella API is quite open, so I believe it will be quite easy to push the results back to update the property values in the model, but at this stage, it's not available. So let's get started. I will show you what it looks like. So I will go inside Capella here. You can see the toy catapult project. So again, the 3 first layers have been addressed in the tutorial. You can see that we have a logical architecture here. So we'll open it up just to show you that's the starting point, right? So we have different type of actors. We have the child, we have the parents, we have different functions that are being performed. We have different flows between different functions, and we have different logical components. So energy storage, projectile containment, lock and release, for instance. We decided to go into the physical architecture. So what I did is that I created this class diagram. So you can see the different classes that we created, right? With the composition relationship, the different requirements linked to the classes here. And of course, you can see on the left, for instance, for the catapult objects, that we have 2 types of parameters. We have the PVMT properties here, and we have classic standard properties as well that are being used in the model with some starting values. So at this stage, I would like to see if the architecture I put together with the baseline are meeting the requirements. So what I will do is that I will go to the toy catapult at the top, right-click, launch ModelCenter MBSE. So it will start the plugin, right? And the first thing I would like you to remark is that ModelCenter MBSE is parsing the model. So on the top here, it's a little bit small, so I will zoom in. You can see the different packages of the Capella model that are being displayed. So we're not going to display each single element. At this stage, we will only display parameters and properties, right? So if I go into my structure, into my data, sorry, you can see that we have the catapult. The catapult has an aiming mechanism with different properties. At the bottom, you can see the requirements. And in the middle, this is a list of analyses that we already connected to the Capella model. So how can we create a new one? Well, you just have to click here on Add New Analysis. I will connect to the local host where my analyses are located at this point. I have my Capella webinar repository, and the workflow with MATLAB I showed previously is here. So we'll go ahead and double click. And what it will do is that it will basically load this component as a black box. So you don't have the ownership of the model, so you can't open it up, but you can visualize the set of inputs and outputs in this model. On the left-hand side, I can see basically the project explorer of Capella. So I go into data, I go into catapult system, I go into my catapult, and on the right, you can see the list of input and outputs coming from the workflow. So I need to provide, to do the mapping right now. So the arm mass needs to be connected to the arm mass. So we'll go ahead, I will create a link. I will do the same thing for the projectile mass here. So that's a property value, actually, projectile mass. And for the rest, since I don't want to lose too much time and I had an appropriate naming convention, I can select a class and I have an auto link. So ModelCenter MBSE will automatically detect the Capella properties and the simulation variables that have the same name. So I can automatically create links, and there is a unit checking as well behind the scene. So at this stage, it's okay. I can save it, right? And my analysis will be saved here in the library of analysis. So if I'm in Capella, I'm a system engineer, I want to run this MATLAB model against my Capella model. I just have to drag and drop it here. It understands all of the properties of the Capella model that are at stake. It's taking here the baseline, so I can change the value, and I can run. When I run, behind the scenes, ModelCenter will call MATLAB, will get the results, and will send them back to Capella. So here, behind the scenes, we should see MATLAB that is starting a session. So you can see here the trajectory and all the results that are being brought back into the interface. So it provides, it can really help you challenging the model and get simulation feedback on the architecture you put together. So at this stage, I want to verify requirements as well. So I can go ahead and create a verification analysis for my requirements. So same thing here. I will browse to the Project Explorer, and I will basically here go into my launch distance requirements. So I can see the details here. So it's not perfect. You can see that I have some HTML issues, but you can see that the projectile should be thrown at least 20 meters away. So I have some templates here to verify the analysis. I can decide to go ahead, use a greater than type of analysis. For each requirement, I have a Boolean is satisfied variable and a margin parameter that are associated to. I need to specify the boundary for the requirement. So here it's 20. And I need to connect it to the property in the model as well. So here we want to connect it to the launch distance, basically. So we go here, data, Catapult system, the Catapult launch distance. So we connect that to the value here. We can go ahead and give it a name. So rec verif launch distance, for instance, applied. At this stage, I can not only simulate the system, but I can actually verify the requirement associated to it. So same thing, I drag and drop here. I can see that, this launch distance is used in two different analyses, in the simulation and in the verification. There is a unit check, right? So here I have a unit issue, right? It's good. And you can see the requirement that will be verified by the current set of analysis. So I can hit the run button once again. And this time, hopefully, if it works, it's going to once again call Capella, update the values for the system parameters, and at the bottom here, give you, an indication regarding the requirement satisfaction. So here you can see that, with the baseline, I'm satisfying the launch distance. It's kind of cool. So getting back here, I will go back to my slides. I think time-wise, we're doing well. We're launching we are going to the part 3. So what's the value that is being brought here? So first off, you can connect your simulation models, any type of simulation tool, to your Capella model. So in terms of source of truth and connecting, to the source of truth, in terms of digital engineering and traceability, it's kind of good. You can challenge and run actually the system baselines, use the system baseline to see if the system is behaving correctly. You can run what-if analysis, you can verify requirements, but you can also carry out trade studies, and that's getting interesting. So as a system engineer, you have a wide range of options for the type of, arm for the catapult, the type of wheels, the type of material for the buckets. You can change the dimension of the arm, for instance. And of course, it will affect different KPIs for the system. So the accuracy, the distance, the cost, the mass. And there are some requirements as well. So the idea is to basically give you the possibility to automatically run a wide range of configurations. And on top of that, giving you access to a wide range of visualization tools to make sense out of this data. So you have it's really user-friendly interface. You change the sliders and you can see how it affects the results. So we'll go into the live demo because I think we need to accelerate a little. Here, for instance, I want to run a parametric study. So I want to see what's happening on the launch distance when I'm changing the launch angle, right? So I will tell ModelCenter here to change the launch angle between 0.3 and 1 radian. And I'm going to see what's the effect on the total distance, right? So here we'll go ahead. It's loading, right? I will, again, drag and drop the launch angle here. Starting value 0.3, ending value 1. I want 8 runs. and I want you to tell me what's the impact on the launch distance. So if I run that, ModelCenter is going to iterate, right? It's going to change the launch angle. You will see that the trajectory in blue will change. You know, it will go like more parabolic. And all of the results are being summarized in this table at the bottom. And I have access to a wide variety of views here, right? So if I want to see, you know, the just a simple 2D scatter plot, I want to see, you know, what's the impact of the launch angle on the distance. So here I want to make it a little bit bigger so that you can see. All right, I will add a filter here, launch distance. So you can see that, of course, I mean, when you increase the angle, the distance is increasing a bit and then plummeting. So we have a requirement on the distance. It needs to be higher than 20. So we have a slider here. And as we are changing the slider, it will update the view. And you see that you have some points grayed out here. So they are not satisfying the requirements. And it looks like this one is optimal. So this is the point we'll use for like from now on, right? We'll update the baseline in Capella. So I don't have time to set up like a more complex design of experiment. I just want to show you here, if I create a new execution plan, in this example, I created a wide range of analysis. So you have Excel catalogs, you have Python scripts, you have more complex workflows with more complex solvers behind the scenes. You have 6 requirements that are being verified at the same time. So of course, we have more parameters from Capella that are being used. So that's the baseline, right? We can even change, you know, like the type of the aiming type for the catapult. So here it's a visual sight. We have laser sight. We can change. We can change the type of the bucket material, for instance. So I will just launch that behind the scenes. And while it's, you know, computing, I will show you the rest. You can see that there are some variables that are used for actually many simulations. You can see here. You don't have to build the workflow. You have 15 analyses, but ModelCenter is taking care of, you know, considering the relationship between all of them, creating a master workflow behind the scenes, calling the different solvers one after each other, and we'll bring back all of the results into this plugin inside Capella, right? So it's really modular. You can have Excel at first, and then later on you replace it with a more complex solver. So you see that MATLAB is being called. You know, it's really like modular approach. So here you can see the results. You can see that it's giving great feedback. So we can see if the, you know, the catapult accuracy has gone up, for instance, but at the same time, you know, the total mass, the total cost also has, you know, reduced. So that's good. You can see the requirement status at the bottom. So here we're talking about more requirements, and this is where it gets interesting, right? We will have to run thread studies. You know, we can't optimize each single objective independently. We will have to do a trade, right? We can't have the costs, reduce the cost and at the same time have the best performance ever. We'll have to meet a trade-off here. So one thing I would like to show you here is that we can save all of this data. So here I can save this execution plan, for instance, as a Capella webinar. This is being saved in the plugin. And this is being saved inside Capella as well. So it's basically linked to the project. It's keeping track of the ModelCenter MBSE DB file in the Capella project. What we don't have at this stage, and we have in other modelers, is the ability to push the results back. So save baseline values, and for, you know, instances doesn't really apply to Capella, but having the possibility to push the results back, right, at this stage. So if you run a more complex design of experiment, and I did it, so I won't have to run through it, you can get such table, right? And it's huge. You get like here 800 points. We want to add a view. Here I'm just going to show one of them. A 3D scatter plot, right? We have 6 requirements. We have a design space that is really constrained. So I want to change a couple of things here. I want to show you how easy it is to use. So I want to change the dimensions. So first off, the costs are interesting too. The launch distance is also interesting to me, right? I want to maximize it. And I want also to maximize the accuracy. So for this study, it will be minimize it, actually. At this stage, I can start adding some objectives. And I can have many, right? I want to maximize the launch distance. I want to optimize the accuracy. And I want to minimize the cost. And you can see here that something cool happens. It's adding colors to the graph. And for those of you that are familiar with it, we're going to show the Pareto front. And here we have a beautiful, surface of Pareto points. So you can see that we can't optimize each single objective at the same time. We will have to run a trade. We will have to trade between the different objectives. And I can add constraints, right? So I have requirements coming from the system model directly. Here I can add constraints. So all of these Booleans are playing to some requirements. So we can force them to be true, right? We want to basically hide the candidates that are not good enough for us. So that's what I will do here. And it will gray out all of the design candidates that are not good enough. So this is really good for the system engineer because it allows them to identify the solution pockets. So we'll be able to select the best architecture and select the baseline before we are basically sharing this work with the simulation experts, right? So for instance, here I could decide to use this point that is Pareto optimal candidates, and I can see the values. So it's wood for the wheel. Of course, it's cheaper. It's laser steel for the aiming type, and it's wood as well for the bucket, right? So getting back to my slides at this stage, there is one last part before I open it up for the last poll question. There is the possibility in the plugin. So the plugin is bidirectional, as in like it can be used from within Capella and can be used within ModelCenter. So two different perspectives. If you're a system engineer, you will most likely use it from Capella. If you're more, like using simulation models and not really familiar with Capella, the plugin is also accessible to give you access to the properties that you define in Capella, as well as the requirements. So we have the dedicated plugin for it. And I will show you what it looks like. That will be the last part of my demo here. So I will go back into ModelCenter at this stage. And you can see here, if I go into Tools, Trade Study Plugin, I have a ModelCenter MBSE connector for Capella. So if I click on it, it will actually understand that there is a Capella project that is open on my machine, so I can select it. And it will load the execution plans that I created previously. So I can visualize them here, right? So I have some analysis that have been connected, and I am verifying some requirements already. I have access to the baseline in Capella. I can actually build the workflow. So here I have a bunch of analysis. When I run that from Capella, actually, I don't see the workflow, but here I can see it. So I will ask ModelCenter to build the workflow so I can see it in real time here. If I double click, you will see that it's actually considering each single analysis, and it will analyze the interdependency, and you will see like perform some mapping, parametric mapping between the different blocks. So that's quite powerful, right? You don't have to do any of that. It's fully automated. And the last thing I would like to show you is the fact that, yeah, as a simulation expert, even if you don't have limited experience of Capella, with the tool, we give you the possibility to access to the Capella information, the Capella parameters here. So you can see here physical architecture, data, you see the different blocks, different classes, and you see the different requirements as well, which means that you're connected to the up-to-date set of requirements here. So if I run everything here, it will run everything, and I'm consuming information coming from Capella. So being aware of the time here, I want to keep some time for the last part. So I will get back to the slides. I have one final remark here. Of course, other physics and disciplines could have been considered, right? Structural, fluid analysis, multi-bodies, dynamic simulation, crash simulation, you name them for this specific example, right? And other catapult architectures could have been studied. So that's what Peter Jackson in the tutorial was mentioning. Here we are, I think it's an onager that we are considering, but we could have traded between this type of catapults versus a ballista versus a trebuchet, for instance, right? So I hope that you liked the demos, right? It went, I think, quite well. I will open it up for the last poll question. So what do you think of the current capabilities offered by ModelCenter and Capella? That's the first one. What features, capabilities would you like to see added to the connector? So when we talk about connecting simulation to Capella, what we showed to you today, is it something that is valuable? Were you thinking of something totally different ways of interacting with Capella, right? So we provide all of the feedback here. It can be short. There will be a survey afterwards. So please give us some feedback. so that we can make it work better, and hopefully, you know, one day we'll start using it. In the meantime, I think while you were answering, we can open the floor for question and answers. So Samuel, did we have any questions at this point?
Sure, we have. Okay, so let me jump to the Q&A. Well, Scott already answered a few of them. I will start with those one. Okay, so the first we had is Ansys ModelCenter a model repository or library management system?
Yeah, Scott, do you want to take it? I mean, I can take it. So ModelCenter has to be seen as a what we call PIDO tool, right? Process integrator and design optimization. So it's a tool that will orchestrate the execution of different simulation models, right? So it's pretty much, you know, automating the different simulation tools and creating a workflow and automating the execution of this workflow. ModelCenter is not a, you know, like could be SPDM or a model repository tool. So we don't want to store all of the information. We're not going to store like each versions of the simulation models. We have other technologies within our company to do that. So that's not available in ModelCenter. And Scott, I don't know if you want to add to that.
No, Alex, we have already answered most of these questions in the chat. So I would suggest that we move to the new ones for the purpose of this Q&A.
Okay.
Yep. So
the next you answer.
So Alex, there's one that I did not know how to answer. I'm just going to read it to you. You may not know either, but the question is, in your Capella model, it seems that you're using data objects in place of physical assets. Is there a reason for this?
Yes, so that's a really good question. As I explained, you know, we want to be fully transparent with you guys. So when we went into the physical architecture, I started by creating, you know, physical assets. So physical blocks, just for you to understand, Scott, like physical blocks, right? You can add properties to them as well. The problem is that when you start ModelCenter MBSE, it's not interpreting this data correctly. I mean, these physical blocks. So it's considering them, for instance, as a property and at the same time as a package. So we have a visualization problem. So we decided to go with data model because I think it's still carry across the idea really well. At the end of the day, what we would like to do is to connect to any type of entity that owns parameters. So it would be the same for data object or for physical assets. And that's why we didn't show it today.
Thank you, Alex.
Okay, thanks. Okay, is it possible to persuade the MATLAB simulation in the current design of experiments trade-off?
Yeah, so, and you might want to say something too, Alex, but it's not really multi-threading, but we can set up ModelCenter so that it will take multiple MATLAB simulations and run them in parallel. So that is possible, yes.
Yes, indeed. And it's possible not only for MATLAB, right? For other tools as well.
For any tool.
Yeah, the only limiting factor could be the number of licenses that you have available for the tool you want to run. But ModelCenter can help you, you know, parallelizing the execution of the simulations.
Okay, do you expect to exploit information from Capella scenario as a constancy check of system designs for fake changes?
So for this,
yeah, go ahead, Alex. I was just going to say that's potential future work. We don't do it today, but if that's something you would like to see, let us know in the poll question.
So that was an interesting one for the type of where is it written? Type of connection supported, I think, in the data diagram, in the class diagram. Here I use composition. I think it's not a problem. Like I use composition because in ModelCenter MBSE, what I want to see at the end of the day is I have one system, and this system, you know, is composed of different subsystems with different parts and multiplicity involved. So basically, it's to provide a context, right? When I connect my simulation models to Capella, I want to be able to say, look, I'm actually connecting to the wheels that are part of a vehicle. I don't want to connect to any type like of wheels that are independent from the vehicle. But I mean, if you decide to create a model using different types of links between the different blocks, it's not a problem. We will still be able to interpret them in ModelCenter MBSE.
And then, Alex, there's one other question that we haven't been able to answer, and I can't answer it because I don't know what it is. But the question is, does it, and I'm not sure what it is, probably ModelCenter, provide connection with openPlcxml format for PLC? Yeah, and thank you, Samuel. For the question.
Does it always provide? I'm not familiar with this format, to be honest. Yeah. So I might be able to take this one online.
Me neither. So
I mean, PLC is product lifecycle, but openPLC.
Yeah, we can research that and get back to you with the answer to that.
If you could maybe provide more information, right? Like provide connection, as in you want to consume an XML file. It looks like a type of XML extension, right? You want to be able to parse it and extract this information with ModelCenter, or do you want to publish some kind of results to this format to respect the given standard? Yeah.
Okay, so I think we covered, because we have a lot of redundancy questions, so it's not easy to.
Yeah, I think everything's now been answered.
Yeah, I'm seeing just another one. The last one, another useful thing would be the generation of mathematical expressions from requirements to verify the requirements in ModelCenter MBSE. So, I mean, this one, again, I want to be transparent. So far, we have a better integration with Cameo in the way that, you have a glossary that you can activate that has some intelligence behind, that will scan some requirements linked with a satisfied relationship to blocks. And based on that, automatically generates constraint analysis, constraint blocks that are part of the meta model. And ModelCenter, based on that, can automatically generate a verification script. So it's more automated than what we have today. But yeah, maybe you can help us, like maybe there are some things that we can add. We can add parameters to requirements in Capella. We could further exploit that with you.
Okay, and we received this question in the meantime. So could ModelCenter be used as a bridge to allow model information to be exchanged with other MBSE tools?
That is an interesting question. ModelCenter was not designed to do that. It's possible that you could set up a ModelCenter workflow that would help you do that, but there's no specific intent to use ModelCenter to do that. I would probably point you to third parties such as Sodius, if you really wanted to do that.
Yeah, I just added the contact information here. So don't hesitate if you have questions, reach out to Scott or myself. It will be a pleasure to answer those. And I mean, again, you can ask Scott. I pushed hard to get this plugin developed. We are getting there, but now what we need is truly feedback from the community so that we can make sure that we don't develop something that doesn't make sense to you, but that we can develop something that you would use, right? So thank you, everyone.
Yeah, thank you, everybody, for attending. It's been a pleasure.
It was our pleasure. Thanks. So just to briefly conclude, I just would like to recap our next events. So very soon, Capella will be present at the INCOSI International Symposium. So if you pass by Hawaii next week, feel free to come and see us on the bus. It would be a pleasure to meet you in person. Then you can already save the date for the next Capella webinar, September 14th. So Pablo Lopez-Negro from Ansys will present Attica, model-based safety analysis workbench. And as a reminder, the Capella Days will be held in November, so it's a bit soon to register for the event itself, but if you're willing to share with the community, the call for proposal is open until September 15th, so we are eager to see your submissions. Once again, thanks for your nice insights. Have a good day and goodbye.
Thank you, everyone.